Hi everyone, this is Tosha. Welcome to the online class for theory of computation. So the objective for these sessions will be to understand various computing models like finite state machine, push down automata, what is Turing machine, and we'll also try to get aware with what is decidability and undecidability of various problems, and we'll try to learn different types of grammar. So the textbooks which generally we refer for theory of computation subject is, one is Introduction to Automata Theory, Languages and Computation by Hawcroft, Motwani and Ullman. Another book is Introduction to Languages and Theory of Computation by John C. Martin. Before getting into the depth of the subjects, let's first try to understand what is our subject title meaning, what is the dictionary meaning of theory and computation. Okay, so the word theory here means an idea that is suggested or presented as possibly true, but that is not known or proven to be true. So any set of ideas which is not proven to be true, right now we don't know whether our ideas will be a successful idea or it will fail, but it is a suggestion of ideas which is intended to explain some facts or events. Here the word computation, another word, the computation means a general term for any type of information processing that can be represented by an algorithm precisely. So here algorithm means any finite sequence of simple instructions that is guaranteed to halt in a finite amount of time. So information processing regarding computation, it can be regarding like adding two numbers, either it's on a piece of paper or using calculator or in our brain, or converting a decimal number to a binary or vice versa. So these are our computation where information is getting processed. Okay, 1 plus 1. So some input is going, some processing is being done, and how we can represent it with the help of some sequence of instruction, that first take this input and after that apply this operator, like this, some finite instructions, some finite sequence of instructions we are giving, and at the end definitely we will get an output. It will halt in a finite amount of time. We will get some output. We will get it will guarantee to halt. So this is the meaning of theory of computation. So the general example is ATM. Okay, so the ATM machine, you can see the ATM machine, we are giving some input, some ideas. First we figure it out that yes, the card will be there, there will be some sequence of numbers will be there. Okay, once it is getting inserted in that ATM machine, if the card, the sequence of events are genuine, then it will ask for pin. The pin is correct, then the next step it will be, and finally we will get the cash in our hand. So that final step is called in a final step. The output we are getting in finite amount of time. So some ideas, some blueprint for our machine, how a machine should work, with the help of some algorithm, with the help of steps, and at the end in what amount of finite time the input should come, and what the output should come. So that is the meaning of theory of computation. In this, let's start with automata. The term automata. Automata, it's a plural of automaton. A singular term is automaton. Automata is a plural term. So what is automaton? It's a device that functions automatically. Automaton, the word auto, from itself we are getting a hint, right? So it functions automatically, or we can say it's a self-operating thing. It's a kind of machine, self-operating machine, which will take some input, okay, and it will go to finite number of states, and finally it will enter into a finite state. Such type of machines are called as automata. Okay, such type of machines are called as automata. So in that we will see finite automata. What is finite automata? Okay, so just now we saw what is automata. Automata means a kind of state which will be state. It will take input. It will take input. Input will go through finite number of states. Enter a final state. Okay, so that is your finite state. That is your finite state system. Finite state system means a mathematical model of system with certain inputs, and the model will finally reach a certain output. So for example, any machine is there, in that you want to check the spelling, okay, spelling of a particular, in English, spelling you want to check. For example, the spelling is then, okay. So this term you are giving to a machine, and the machine finally it is telling whether the spelling is correct or not correct. So what is happening here? The input you are giving to a machine, it is processed by various states, and then the various states, when it is processed by various states, those various states are called as intermediate states, okay. Those various states are intermediate states, and then it is reaching to a final state, okay. Final state you are getting, maybe it is a wrong spelling, or it may be a right spelling. At the end we will get some output. So finite, the word finite here, so finite means that these type of machines will be having some small amount of finite amount of memory, okay. Automata means a machine, right? A machine, a self-operating machine. Finite automata means a machine which is having small amount of memory, okay. Self-starting, self-operating, small amount of memory it is having. And these models means these models are used for small computers and all. They will be accepting or rejecting any input depending upon the pattern of the finite automata, of course, in the input. So one example is on your screen. You can see this is, the example then, then. We need to check the spelling then. So the word then is our input right now, and here it is going word by word. So first T, see here T, it is going, it is checking, yes, correct. So next the input is H, it is going, okay. So in the next machine, yes, the input is written TH, so up to this the spelling is correct. And in the next state when it is going, it is THE, okay. So the next in the input string, the next symbol is E only. So we have right now, we have correct spelling THE, and the next state is THEN, and in our input string the next symbol is N. So up to then THEN, so up to then we got the correct final output. Yes, this is the correct spelling. So these type of finite automata we will be using in the lexical analyzer. We will be seeing in further classes. The lexical analyzer means it's a program which scans your program character by character. The way right now I check the spelling of the word THEN, okay. So character by character it will check and recognizes those words as token. So in this such type of lexical analyzer and all, we will be using finite automata. Definition of finite automata is, the finite automata is a collection of 5 tuples, okay, which is Q, sigma, delta, Q0, F. So what is Q? It is finite set of states. As we saw, all these circles, whatever these circles, these are states, one state, okay. In this state, like in ATM, set of states, what the set of states will be, one state will be inserting the card in the machine, one state, okay. The card is getting accepted with right code, okay. Next state, the third state, it can be like the pin codes, okay. The pin which you entered is the correct or not. So these are the set of states. At every the input is reaching to this state, if it is getting accepted, okay, then go to the next state, okay. So these are set of state. And next is sigma, that is finite set of input symbols. Here the finite set of input symbols are T, H, E, and these are our finite set of input symbols which we are checking with in this machine. And then Q0 is the initial state, okay. Always this start state, that is our Q0 initial state. F is our final state, means where we will get some output, and this delta is the transaction function, okay. So transaction, here the transaction function is a mapping function. It is used, this function is used to move to the next state, to determine which will be the next state. From this state, what will be the next state. So this delta will tell us, okay. We just now saw some circles and arrows. Actually these represent, these circle arrows represent transaction in the automata. Okay, so this circle is the states, in the states. Okay, if input is entering here, all the criteria it's fulfilling, it is moving to the next state. Okay, when it is moving to the next state, that means transaction. That transaction is represented by the arrow symbol. This is state transaction. So I can give some name. For example, the name of the first state is Q0, name of the second state is Q1. Okay, and I am giving some input. Okay, so I am giving an input A. Okay, if in my input is A, correct. Okay, input is correct. From Q0 input is correct, then move to Q1. So we will be representing that transition with the help of an arrow. Okay, so this is one more thing, the starting state, the start symbol, that is Q0. We said that Q0 will be the start symbol. That is always represented by an arrow here. Okay, an arrow touching this. Okay, so this always will represent the start state with the circle and an arrow. Transition symbol is represented by an arrow, long arrow. And after that, final state, in between intermediate states and all, we will represent with just with a circle, like here, this, the way I represent Q1 on getting an input A, Q0 when we are giving an input, move to Q1. From Q1, if there is an input, for example any input B is there, if it is correct, move to Q2. Okay, now if I want to represent Q2 as final state, then I have to double circle it, twice circle it. Okay, 2 times circle. So representing the final state is with 2 circles. So this is the way to represent the final state. Final state means at that moment, at that state, the machine will be getting a halt position. It will stop. Okay, it will stop either in a getting a successful output or without a successful output. That depends. Okay, so this is the way to represent the automata with the help of circles and arrows. So that is our. So till now what we studied, just quickly just see, we saw what is theory of computation, definition, that dictionary meaning. Then we saw what is automaton. In that we saw what is finite automata, and the 2 types of finite automata we will see in the next class, that is deterministic finite automata and non-deterministic finite automata. So the types of this finite automata, we studied that it is having small amount of memory. This finite automata is having small amount of memory. Input will be given to the machine. It will process through some amount. It will process through some intermediate states, and after that it will reach a final state, right? But memory, small memory, it will be for, and for example the lexical analyzer and all. Okay, and automata is always represented with the help of circles and arrows. Okay, formal definition of finite automata is it will be having 5 tuples, that is Q is finite step, sigma is input alphabets, Q0 is the initial state, and F is the final state, and our delta is the transaction function. Okay, so with the help so for the example which we see, the spelling checking of the word then, for this the first state is this one. Okay, input alphabets are T, H, E, N. Final state is this double circle one is the final state. Okay, and this one is the initial state, final state, and these 1, 2, 3, 4, 5. These are the finite set of states. We can represent it by 1, 2, 3, 4, 5, or we can give it a name as Q0, Q1, Q2, Q3, 4, 5. Depends. Okay, so that's all for today's session. Thank you everyone. Hope you understood this session. See you.